Hello friends, welcome back to my YouTube channel Study of Science with Rahul Kesherwani. Today I will describe the group 17 elements as well as its physical properties, which is the part of P block elements. As you know, in the previous video we described the chemical properties of the group 16 elements. Now this time I will describe about the group 17 elements. As you know, the group 17 elements contain 5 elements. Let's see what elements which contain the group 17. So, elements of group 17 is fluorine, chlorine, bromine, iodine and astatine. Fluorine, chlorine, bromine, iodine and astatine. These elements are called halogens, and this family is called halogen family. Why this is called halogen family? Actually, halogen is a Greek word which means salt forming. Means these elements are responsible for the formation of salt. That's why these elements are called halogen. As if we take an example like as NaCl, chlorine is present in the sodium salt. Similarly, sodium iodide, iodine is present in the salt of sodium. So these elements are responsible for the salt formation. That's why these elements are called halogens. And the family of these elements are called halogen family. Halogen. And the name of these elements is fluorine. This is fluorine. This is bromine. This is iodine. And this is astatine. Halogen, because they are due to salt formation. Due to salt formation. Now, what is the atomic number of these elements? 9, 17, 35, 54, 53, and this is 85. So, these are the atomic numbers of these elements. If we write the electronic configuration of these elements, then 1s2, 2s2, 2p, 5. For chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. For bromine, that is 4s2 and 4p5. And for iodine, this is 5s2 and 5p5. For astatine, the electronic configuration is 6s2 and 6p5. As you know, the last electron of these elements goes in the last electron goes in the p subset, the p orbitals. That's why these elements are included in the p blocks. Now, if we see the valence shell electronic configuration, valence shell electronic configuration, then Ns2Np5, and the value of N is from 2 to 6. Valence electron, that is 7. So this is the basic information regarding the fluorine, chlorine, bromine, iodine and astatine. Now what is the physical state of these elements? Physical state. Fluorine is gaseous in nature. Chlorine is gaseous in nature. Bromine is fuming liquid, means liquid in state. Iodine is volatile solid, means when it kept at the room temperature, then it converts into direct gaseous form, that means volatile solid form. And these have radioactive solid astatine. This is radioactive solid. When we describe the properties of these elements, then we not consider the astatine because this is radioactive element. Now the third physical properties of these elements is atomic size. Atomic size. When we move from top to bottom, then atomic size of element is increases. When we move from top to bottom, then atomic size of elements increases due to addition of new cell. Due to addition of new cell. In this case, only 2 cells are present, 3 cells, 4 cells, 5 cells, and 6 cells. Then the size of elements is increasing. Why? These group 17 elements are smaller than group 16 because higher effective nuclear charge means proton number. Group 16, what is the reason behind this? Why these elements are smaller in size from the group 16? The reason is that due to effective nuclear charge. That's why the size of group 17 is less than the size of group 16. So, now the fourth chemical properties of these elements, that is ionization energy. As you know, ionization energy is inversely proportional to atomic size. Atomic size increases, ionization energy decreases. Means when we move from top to bottom, then the atomic size of elements is increases. So so its ionization energy become decreased. When we move from top to bottom, atomic size increases, so ionization energy become decreases. So this is the trace of ionization energy. But as you know, these elements are smaller in each periods. Means these elements are smaller in second periods. These elements are smaller in third periods. These elements are smaller in fourth periods. Means in the respective periods, these hydrogen elements are smaller in size. So their ionization energy is higher. Its ionization energy is higher as compared to group 16 because it's have less size as compared to the group 16. So group 16 have large size, so its ionization energy is less. But these elements have a small size, so its ionization energy is high. So this is the fourth physical properties. Now the fifth physical properties, that is electron affinity or electron gain enthalpy. As you know, these elements have one less electron from the stable noble gas configuration. These elements have one less electron from its nearest noble gas configuration. If we take example like fluorine, fluorine have 9 electron, and in case of neon, which is the noble gas, which have 10 electron. So fluorine have 1 electron is less from its nearest noble gas configuration. So it have more tendency to get 1 electron to obtain the stable noble gas configuration. So that's why these elements have maximum electron gain enthalpy in the periodic table. That's why these elements have maximum electron gain enthalpy in the periodic table. The trace is due to nearest noble gas configuration to obtain the nearest noble gas configuration. But in case of group, as you know, size increases, then the electron gain enthalpy decreases. But the order is not in the well arranged. Now I describe the electron gain enthalpy concept in group. In group, the electron gain enthalpy is in the order. Chlorine have maximum electron gaining enthalpy, then fluorine, then bromine, then iodine. Why this happen? Actually, see, this is fluorine and this is fluorine. Fluorine have 9 electrons, fluorine have 17 electrons. So, in case of fluorine, this is the nucleus, 2 electron, 1, 2, 3, 4, 5, 6, 7 electron. In case of fluorine, 1, 2, and 3. Bases are present. This is nucleus, 1 and 2 electron, 1, 2, 3, 4, 5, 6, 7, and 8 electron. In the outermost, there is 7 electron. When electron is added in case of fluorine, then the size of fluorine element, fluorine atom is small. Means electron density of fluorine is present in a small size. That's why the electron is added to the fluorine, then it gets repelled because all the electrons present in a small size, they have more repulsive power. So that's why this electron is not easily come to the fluorine atom. While in case of fluorine, the size of fluorine atom is large as compared to the fluorine, then the coming electron is so much easily accepted as compared to the fluorine. That's why the fluorine have higher electron gaining enthalpy as compared to the fluorine. When we want to add this electron into fluorine, we also provide some extra energy from outside. That's why the liberated amount of energy become decreases. So the order is fluorine, bromine, and iodine. So this is the traits of electron gaining enthalpy, which is very important. If anybody asks you why the fluorine have higher electron enthalpy than fluorine, then your answer is due to the small size of fluorine, the coming electron and the electron present in the fluorine get repelled, and we give the extra amount of energy from outside to add this electron in the fluorine atom. But in case of fluorine, the size of fluorine atom is large as compared to the fluorine, so the one incoming electron is easily added to the fluorine. That's why the fluorine have maximum gain electron enthalpy as compared to the fluorine. So this is the fifth physical properties of hydrogen. Now the sixth, 3.0, 2.7 and 2.2. So when we move from top to bottom, electron negativity decreases. Top to bottom, electron negativity decreases. Now the seventh property is non-metallic character. As you know, these elements have high ionization energy and high electronegativity. So these elements have maximum non-metallic character, because high ionization energy means they require much more amount of energy to remove one electron from its valence. So these elements shows the non-metallic character due to high ionization energy and high electronegativity. Now the eighth properties is color of these elements. Fluorine have light yellow color. Chlorine have yellow green color. Bromine have reddish brown, and iodine have deep violet. So these are the 8 physical properties. Now the next physical property is melting and boiling point. When we move from top to bottom, atomic size increases. That's why the van der Waals force also increases. Van der Waals force increases from top to bottom. So its melting point and boiling point also increases. Now the 10th physical properties is reduction potential, standard reduction potential, and oxidizing nature. As you know, these elements have positive reduction potential. These elements have positive reduction potential. So they are the strongest oxidizing agent. Means they have property to accept one electron so much easily. So these are the some physical properties of group 17 elements. So thank you for watching this video. Like this video, share this video, and also comment in comment section box. And also don't forget to subscribe this channel. Thank you.